So one final example of us being able to compute the principal unit vector at a specific point. So now we have this function r of t, 6 cos t I plus 6 cos t, or 6 sine t j plus k, where t is going to be equal to pi. All right, so first thing we have to do is we have to verify that it's smooth. All right, so if I was to verify it's smooth, which it is, but that's okay, r prime of t is going to be equal to minus 6 sine t plus 6 cos t, and that's an I and a j. Right. When we substitute pi back in, that's going to be minus 6 sine of pi I plus 6 cos of pi j. Sine of pi is 0, and then 6 sine of 6 cos of pi is going to be negative 6j, which is clearly not 0. All right, so it is smooth at that point. All right, so that's good or bad depending upon how you view it, because now we actually have to do the problem. The graph, we can use that trick once again, where we can go through and just try to parameterize it. So let's let x be equal to 6 cos t, y equals 6 sine t. We're going to square both of these, so we get x squared is equal to 36 cos square t, y squared equals 36 sine square t. And if we add those, we get x squared plus y squared is going to be equal to 36 cos squared plus sine squared of t. We clearly know that that's going to be equal to 36, not 316, but 36. And so we end up with x squared plus y squared is equal to 36. Right? So if we were to plot this function, right, and notice that the k is always 1 no matter what. All right, so each time we plot it, it's just in 3 dimensions. It's just going to be one of these types of functions where it's just going to keep going up forever. All right, so, or not up forever, excuse me, it's always going to be 1. So imagine it just being a circle of radius 6 when z is equal to 1. All right, so in 3 dimensions, I'll do my best to graph this. So we have z equals 1, and then we just have a circle that goes around that. All right, so just think of it like that. I know that's not a good circle, but just imagine it doing that. And the orientation is going to be counterclockwise. And if you don't believe me, that's fine. All right. But it is going to work out to be counterclockwise for us. All right. And what we're really looking for is we're looking for what happens at pi. All right, so probably right around here. All right, I'm going to graph this in 2 dimensions, so it might be a little bit easier to work with. All right, then just imagine that this is a circle of radius 6, and this is where we're really interested in, right here, when t is equal to pi. And that's the xy point, negative 6, 0. And we can get that just by substituting back in right here. All right, so now we have to try to find t of t and then n of t subsequently. And n of t we need at pi. All right, so this one, although it looks pretty rigorous, it's actually not going to be too bad because of the sine and the cosine. All right, so we already know r prime of t. R prime of t was minus 6 sine ti plus 6 cos t j. The magnitude of r prime of t, and this is where it's going to be really nice because of the sine and the cosine, is equal to the square root of negative 6 sine of t squared plus 6 cos of t squared, quantity. And you can see where this is going really easily by Pythagorean identity. This is going to be equal to the square root of 36 sine squared t plus 36 cos squared t, which is equal to root 36, which is equal to 6. All right, and that makes it really nice because now we can find t of t, and t of t is going to be minus 6 sine ti plus 6 cos tj divided by 6, or in other words, t of t is going to be equal to minus sine ti plus cos tj. Right. Now we have to find n of t. All right. Now remember, n of t is going to be equal to t prime at t divided by t prime at t magnitude. All right. So that's our formula. T prime, and I'll just write this out immediately, that's going to be negative cos t minus sine t. Right, so I just took the derivative of t, and we're going to divide that by each of those squared. Right, so that's going to be minus cos squared, cos of t squared, plus negative sine of t squared. Clearly that's going to end up being 1. So n of t is going to end up being minus cos ti minus sine of tj. All right, so let's hold on to that. Let's also hold on to t of t, because we're going to use both of those. All right, so this might be one of the few examples where t of t or n of t might be easier to find than t of t. All right, now remember, we need n at pi. So we're going to do this. We're going to find t at pi, and we're also going to find n at pi, right? Just to see what's going on at that point pi. And it's actually not going to be all that difficult nor surprising. So t at pi is going to be minus sine pi I, which we like, plus cos pi j. That's just going to be negative j. Right? So we're going to hold on to that as t of pi. Now n of pi is going to be minus cos pi I minus sine pi j. And that's just going to be equal to positive I. All right, so both of those are really nice and easy. And it's pretty obvious that both of those have a magnitude of 1. So they're clearly both going to be unit vectors. Right? Now let's go back up and plot these and finish it off. All right, so here's our vector. Right. I'm going to plot n first. Okay, so n is going to be in red. And we said n was minus j. So really we're just going to go down 1 unit. And that makes sense because remember the orientation is going to do this. So t of t, so when we plot t, it should have the same direction as the orientation. All right? And it's just going to go down 1 unit. So that's our t at pi. All right, so now remember, we also had n at pi, and that was I. All right, so that means we're just going to move to the right 1 unit, and that's our I right there. I'm going to try to make it a little bit bigger. Clearly, they form a right angle. All right, I don't think anybody would dispute that. All right, so it's a terrible right angle, but the good news is they're orthogonal, and that verifies that t and n, at least for this particular problem at pi, are indeed going to be orthogonal. All right, so hopefully this gives you a good overview as to being able to compute unit tangent vectors and then principal unit vectors as well.